Hello students, in this video lecture I will explain you about electronegativity or electron negativity. Let us go by the definition first. It is the tendency of an atom in a molecule to attract the shared pair of electrons toward itself in a molecule. Yes, so what is electronegativity? Electronegativity is a tendency of an atom, okay, in a molecule to attract the shared pair of electrons toward itself. Okay, for example, say if I take a molecule, now electronegativity comes into account only when there is a sharing of electron goes on, right? So it is a nature to measure the strength of a covalent bonding. Okay, now so let us write electronegativity. So what is electronegativity? So it is the nature, electronegativity terms is specifically used for covalent bonding. For covalent bonding. Okay. Now in covalent bonding what happened? Two atoms, they shared their electrons. They shared their electron pairs. Right? Two atoms, they shared their electron pairs. Now electronegativity is a tendency that if any of the atom, okay, can attract that shared pair of electron more toward itself. So how much they are attracting the shared pair of electron, that is electronegativity. Okay, so it is a comparative term, it is a relative term. Okay, let me give you an example. For example, in case of hydrogen chloride, what happened in case of hydrogen chloride? See, hydrogen is having one electron and chlorine in the outermost having 7 electron. 1, 2, 3, 4, 5, 6, 7. This is the Lewis dot structure I am drawing. Okay, so in the outermost orbit it has 7 electron. Now in this case, sharing of electrons take place. Why? Because hydrogen has to complete its duplet and chlorine has to complete its octet. So there has to be a sharing, mutual sharing of electron will take place. Okay, so what will happen? They will share this electron, yes, and go for a covalent bonding. So in this case, hydrogen will have complete its duplet. You can see hydrogen one electron already it has, another electron it will complete its duplet. Whereas chlorine will complete its octet, 1, 2, 3, 4, 5, 6, 7 and then 8. Okay. So hydrogen has acquired the nearest noble gas configuration of helium, whereas chlorine has acquired the nearest noble gas configuration of argon. Okay, whose atomic number is 18 and helium atomic number is 2. Clear? Now, in this, who is more electronegative? Whose tendency or whose power is more to attract this electron? Chlorine. Right? So what chlorine will do? It will attract this shared pair of electron more toward itself. Understood? Yes? So this tendency is measured in terms of electronegativity. Okay, so it is a tendency to attract the shared pair of electron toward itself. Got it? Understood? Okay, so it is the tendency to attract the shared pair of electron toward itself. Okay. Now, it also gives rise to a term known as polar and non-polar. You will see it is given in your book. Okay. Polar and non-polar. See here. Non-polar, polar. Okay, so this type of terms you will get in electronegativity. Now let me explain what is non-polar and polar. So after understanding the concept of electronegativity, now you can see here chlorine has attracted this shared pair of electron toward itself, which mean now electron is having negative charge. Yes, electron is having negative charge. So if more number of electron get shifted toward the chlorine, then what will happen? Chlorine will have a partial negative charge. It is given by this partial negative charge, delta minus. Okay, whereas hydrogen will acquire a partial positive charge, right? Hydrogen will acquire a partial positive charge. So we can also show hydrogen HCl. See, this is a covalent bonding, and I will show okay, with an arrow, that the direction of the movement of the electron, the direction of the movement of the electron. So in this way you can see that chlorine has acquired the partial negative charge and hydrogen has acquired a partial positive charge. Now why am I using the word partial? Because this is partially the electrons are shifting toward, there is no complete donation. Okay, the complete donation or transfer of electron take place only in case of ionic bonding, but this is a case of covalent bonding. In covalent bonding there is mutual sharing of electron take place. Now in this case what is happening, chlorine has more power to attract the shared pair of electron toward itself, right? So this tendency is known as electronegativity. Okay, so since we are measuring a tendency, so it is having no unit, you cannot have any unit, or we don't have any unit of electronegativity since it is a tendency, okay, to attract the shared pair. Now here in this case, if any of the atom is more electronegative, okay, then what will happen, it will attract the shared pair of electron more toward itself. In that case we will have polar, we will have partial charges develop. Pole mean here charge, okay. So this is a polar covalent bonding, so I will write polar covalent bonding. So this is the example of polar covalent bonding, understood? Now what is non-polar covalent bonding? For example, say the bonding taking place between the hydrogen and another hydrogen atom, okay. In that case the shared pair of electron will lie exactly in the center, okay. So this is a non-polar. Non-polar mean if the participating atom or which is participating in the covalent bonding, okay, if all the atoms or if both the atoms are having the same capacity, okay, to attract the electron, so in that case what will happen, both will apply the same force, amount of force, and the net result will be that the shared pair of electron will get the central position. So in that case they will not develop any positive or negative charge. So these type of compounds are known as non-polar covalent compound, okay, non-polar covalent compound, understood? So for example Cl2, O2, N2, okay, so these are all non-polar covalent compound, okay, this is non-polar covalent compound. So non-polar covalent compound where you will see where both the participating atoms have the same electronegativity. But generally what happens in AB type molecules, suppose if you draw AB type molecule, okay, this is a maximum cases what happen. AB type molecules mean, for example H2O, okay, just now I have written HCl, HF, etc. So these all molecules you will see that two different atoms are taking part. So when two different atoms are taking part in the chemical bonding, okay, then either one atom will obviously have the more electronegativity, okay. In that case if they have more electronegativity, the shared pair of electron will move toward that atoms and it will result in developing a partial positive charge and a partial negative charge. Now partial positive charge is always developed in that side where the electron gets shifted, and partial positive charge is developed in that side from where the electron is shifted, understood? So partial negative charge is developed in the side where the electron is shifted, and partial positive charge is developed in that side from where the electron is shifted. So in this case you can see hydrogen is having partial positive charge and chlorine is having partial negative charge, okay. So in this case this is a polar covalent compound, okay. Now what are the factors affecting the electronegativity? Obviously the atomic size. Now if we have already seen in the previous topics, okay, that metals, their atomic radius are more compared to the non-metals, right? Metals have more atomic radius. So obviously if they have more atomic radius, if the radius is more, just imagine that this is the nucleus and say I am comparing two atoms, okay, I am comparing two atoms, and this is another atom of small size. Now this is the nucleus, the center portion is the nucleus. Now just imagine that who is attracting this electron toward the center? Obviously nucleus. So there is an electrostatic force of attraction take place, right? Now if the radius is more, if the distance from the nucleus to the electron is more, okay, there will be less tendency to attract. But if the distance is less, the tendency to attract will be more. Understood? So this is the case of non-metal. In non-metal, the atomic radius is small, and in metal, the atomic radius is quite more. Okay, so we can sum up that atomic radius, with the increase in atomic radius, electronegativity decreases due to the decrease in less attraction by the nucleus. Got it? Nuclear charge. Now if nuclear charge is there, okay, if more number of protons is there in the nucleus, then the nucleus will also have more amount of positive charge. Now imagine if more amount of positive charge is there, then the capacity to attract the electrons will be also more. If the nucleus is more powerful, okay, if the nucleus is more powerful, then it can easily attract the electron toward itself. Understood? So this is known as nuclear charge. That means if more nuclear charge is there, then force of attraction will be also there. As a result of it, electronegativity will be also more. Variation of electronegativity in the periodic table. Now this is important, variation, let's see. Okay, now when you move across the period from left to right, okay, what happened when you move across a period from left to right? So in a period we move always from left to right, yes or no? So you see the metal, all the metals or active metals are in the extreme left, and all the non-metals are in the right. Now non-metals are more electronegative compared to the metals. Okay, non-metals are more electronegative compared to the metals. I am leaving the noble gases. Noble gases, they are exceptional, so leave them. Okay, so non-metals are more electronegative compared to the metals. So when you are moving from left to right in the period, okay, the metallic character decreasing, which means electronegativity is increasing, because non-metals, they have more electronegative character. Okay, always remember, non-metal, they have more electronegative character than the metal. Okay, so no, understood? So which means that if you move from left to right in a periodic table, okay, the electronegativity will increase. Okay, so it will increase across the period due to the decrease in the atomic size. Next, electronegativity in a group. Now what happened in the group? Yes, now when you move down the group, what happens, just tell. Yeah, when you are moving down the group, right, when you are moving down the group, see at the extreme top you will see most non-metal. Okay, and when you move down the group, the metallic character increases. Okay, so if the metallic character increases down the group, which means the electronegativity will decreases, right? Understood? So moving down the group, okay, electronegativity decreases. Understood? Electronegativity decreases. So next, already I have discussed the metallic character in this only. I hope you have understood. Now metallic character, it is defined as a tendency of an atom to lose one or more electrons to acquire a stable electronic configuration. Okay, so it's just the opposite of the electronegativity. So how to measure the metallic character? How easily an atom can lose its electron. So that is the tendency. Okay, so in electronegativity we have seen that how is the tendency to accept the share pair of electron, but in metallic character we will see that the tendency to lose electron. Now here there is no sharing of electron, we are not talking about the sharing of electron, rather losing of electron. Understood? Okay, so to get the stable configuration, for let me give you an example. Say, for example, say sodium is having 11 electron, right? So sodium has a tendency to lose one electron and to change into Na plus. Okay, and Na plus, how many number of electrons are there? 10. Now 10 is the configuration of what? Neon. Okay, so neon is noble gas, so this is a stable configuration. Okay, now this tendency is shown by the metals. Okay, so metals, they have excess electrons. They have excess electron. You just see 2, 8, 1. So this 1 is in excess. Okay, because this is the stable configuration. 2, 8 is the stable configuration. Yeah. So metallic character, how will you find? How will you determine? Metallic character is determined by the tendency, how easily a metal can lose the electrons. Okay. Now, what are the factors affecting the metallic character? First is atomic size. If the atomic size is more, then the nucleus, the distance between the center or the nucleus and the outermost electron will be more. Yes. Now, if the distance between the nucleus and the valence electron is more, in that case nucleus will have very less attraction or very less force, okay, on the outermost electron. So easily that metal can lose the electron. Understood? So which mean if greater the atomic size, then more will be the metallic character. Just now which I said, okay, in the electronegativity also, that if non-metals, their sizes are generally small, okay, whereas metal, their sizes are generally more. Okay. Ionization potential mean what? Okay, ionization potential already I have discussed. Now ionization potential is the amount of energy required to eject an electron. Yes or no? Okay, so metals, they willingly lose the electrons. Which means that we have to spend less amount of energy on metal in order to eject the electron. Understood? Okay, so which mean that ionization potential for metals are less. Okay, ionization potential for metals are less, which mean if you move down the group, okay, from top to bottom in a group, then the ionization potential will gradually, it will decrease. And if we move from left to right, since the non-metallic characters are increasing, now non-metal, they do not have the tendency to give the electrons, right? Rather they have the tendency to accept the electrons. So if you are going against their will, against their tendency, then you have to give more amount of energy. Understood? So in that case, ionization potential will increase for the non-metal. Okay, always check the metallic and non-metallic character, and you can easily predict the other properties as well. Now, variation of metallic character in the periodic table. Already I told you that metallic character, what happened to the metallic character when we move from top to bottom, metallic character increases. When we move from left to right, metallic character decreases. Okay, and what do we understand by the metallic character? How easily an atom can lose electron. Okay, see, which are known as very active metals, sodium, potassium, these are very active metals. Why you know? Because they can easily lose the electrons, right? But there are other metal as well, okay, zinc, aluminium, these are also metals, but their reactivity is less compared to this. Why? Because their tendency to lose the electron is comparatively less than sodium, potassium. Understood? So metallic character is totally determined by how easily an atom can lose the electron. Non-metallic character is just the opposite of the metallic character. Okay, so non-metallic character means how easily an atom can accept the electron, right? For example, chlorine, fluorine, these are all very good non-metal. Why? Because they can easily accept the electrons. So what are the factors affecting? Again the same factors. Okay, now atomic size, if there is more atomic size, then what will happen? In that case, the tendency to attract the electron is also decreases. But for non-metal, what happen? Atomic sizes are less, so they have greater tendency to accept the electron. Okay, so those atoms will be considered as non-metals which are very small in size. Ionization potential. So ionization potential will be more for non-metal. Why? Because this is not the tendency of an atom of a non-metal to lose electron, rather they gain electron. Yes? So obviously you have to give more amount of energy to eject the electrons. So ionization potential for non-metal will be always higher compared to the metals. Okay, similarly the tendency also increases as we move from left to right. So variation of non-metallic character in the periodic table. Non-metallic character in a period, already I told you that when you move from left to right in a period, the non-metallic character increases. When you move in a group from top to the bottom, the non-metallic character, what will happen? Non-metallic character decreases. Okay, so go through this nicely, go through this video lecture nicely, okay, and go through this summary chart and complete the section exercises as I am completing. Okay, very soon I will upload the other part also, so watch this video and go through this. Okay, thank you.